Hello everyone and welcome back to the channel. In our last video, we explored the modern world of GitOps and saw how Argo CD automates deployments. Today, we are taking a step back to a foundational tool that powers much of the DevOps world, that is Jenkins. We will cover what Jenkins is, why it's a cornerstone of continuous integration, and how it automates the build, test, and even deployment process of your software. If you are building a CI/CD pipeline, you absolutely need to understand Jenkins. Let's dive in. So the fundamental question is, what is Jenkins? Jenkins is an open source automation server. It's the central nervous system of a CI/CD pipeline designed specifically to automate the entire software development process. Its primary job is to enable continuous integration and continuous delivery. It takes the repetitive manual work like compiling code, running tests, checking code quality, and deploying, and executes them automatically every time a developer commits a change. The real power of Jenkins lies in its massive plugin ecosystem. Which allows it to connect and integrate with virtually any tool in your tech stack, from GitHub and Docker to cloud providers like and testing frameworks. Before we get too deep into Jenkins, let's quickly review its primary purpose, that is CI/CD. Continuous integration is the practice where developers regularly merge their code into a central repository. Every time a change is merged, Jenkins automatically kicks off a build and runs a battery of tests. This process catches bugs and integration issues early and prevents them from snowballing. Continuous delivery takes this step a further by ensuring that your code is not only built and tested, but also always in a state where it can be deployed to a production at any time. Now let's look at the key features that makes Jenkins such a flexible, powerful CI/CD engine. First, we have pipelines. This is the modern standard allowing you to define your entire CI/CD workflow, that is the stages, the steps, and the commands, as code within a Jenkins file. This brings version control and consistency to your build process. Next is the vast plugin ecosystem. This is where Jenkins connectivity comes from, allowing it to easily integrate with thousands of tools like Git, Docker, Maven, and various cloud services. For large-scale operations, distributed builds enable you to run jobs across multiple agent machines or nodes, helping Jenkins to scale hundreds of concurrent builds. Finally, the UI dashboard. It provides a centralized, easy to read overview of your job status, build history, detailed logs, and giving you the immediate feedback on your development process. Let's walk through a typical Jenkins powered CI/CD workflow. It all starts with the developer pushing new code to Git repository. Jenkins, which is constantly monitoring the repository, it detects this change and automatically triggers a new build job. Inside this job, Jenkins will execute a series of steps defined in a pipeline. For example, it might build a new Docker container image, run all your automated tests, and if everything passes, it will tag the image and push it to a registry like Docker Hub or an internal one. From there, it can hand off the process to another tool like Argo CD for the deployment. Now let's see in the action. We will set up a simple Jenkins instance, install a few plugins, and then create a basic pipeline job. I will show you how to link it to a GitHub repository so that Jenkins can periodically check for new commits. When you commit new code, Jenkins will automatically start a new build. We will see what a successful pipeline looks like, and I will even show you a failed build so that you can see how Jenkins provide feedback to help you troubleshoot issues quickly. All right, enough with the theory. Let's get our hands dirty and build our very first CI/CD pipeline using Jenkins on this completely empty Windows machine. We'll set up Jenkins. We will install a few key plugins and then connect it to a GitHub repository so it periodically polls and builds our code. Before we begin, remember that we are starting completely scratch in a clean Windows machine. Jenkins is basically a Java application, so the first thing we will need is a JDK. I have it already installed on this machine. This is a virtual server. Let me quickly show you the Java version. It is Java 21. So let's now go to the browser. Now, because we have the Java, we will install Jenkins. I will search for Jenkins download here. I will go to the official website, Jenkins website, and download the Windows installer. I will click on Windows and it will download the Windows installer. So once we have this Jenkins installer ready, Windows installer for Jenkins, I will click on it and I will run this installer. Let's click on next and set the default options. Test port, it's available. Next, then next. Okay, the Java version was not found. Let me give it the correct path. For JDK 21, we can next, and install. So it's now installing the Jenkins, and the Jenkins service should now be running in the background after this is done. Once this is done, we can access the web interface right now in this browser. I will go to the localhost 8080. I will navigate to localhost 8080. It's the default port for Jenkins. Okay, so the first time you run Jenkins, it requires an initial administrative password for security. So the screen tells us that where exactly to find it. I will copy this path. It will give me the initial admin password. I will just copy this path and open run and paste this path in it. It is asking me how do you want to open. I will click on notepad and I'll click OK. Okay. So this is the initial password. I will copy this password and paste it in the box and I will click on continue. Great. So Jenkins is nothing without its plugins. For a modern setup, we need a few key plugins. I always recommend starting with the suggested set. So I will click on install suggested plugins and I will click, it will get started. So Jenkins is now downloading and installing core set of plugins. So this includes the pipeline plugin, the Git plugin, and others we will need for the continuous integration. Let's wait for this to get so that it gets completed. While this is running, let me show you the GitHub. So we will need to prepare the GitHub repository in the meanwhile. So let me show you the GitHub repository that I have ready. This we will be using for connecting the Jenkins to GitHub. This is nothing but a sample repository, a simple repository with a single file called Jenkinsfile. Please create this repository in GitHub and with this content. There is a pipeline. This is a syntax in Ruby, basically. As you can see, this is a very simple repository. So I have added this file called Jenkins file. This is a special file that contains our entire pipeline definition. It is written in Groovy syntax and yes. So by keeping it in this repo, we ensure our build process is part of our code, which is called pipeline as a code. Great. So let's go back. Let's verify. Okay, it's almost completed. Let's wait few more seconds. Great, so it's done now. Let's create a first administrative user so we don't have to use that admin password, that initial admin password that we use. So I will give it a name demo and password as password for now, and then confirm password. And I will give it name demo and then email ID, let's say demo@gmail.com. Perfect. So these are the details for the first user. I will click on save and continue. Jenkins URL, let's keep it the default, save and finish. Great. So Jenkins is now ready for us to use. Let's click on start using Jenkins. Perfect. So we are going to now create the job that connects to our GitHub repository. So on Jenkins dashboard, I will click on new item. I will give this item name as my GitHub pipeline. And since this is a pipeline, I will select the item type as pipeline and then I will click on OK. Before configuring the pipeline, make sure you have Git installed on this server because we will be connecting to GitHub. So we need Git installed in this. So go to triggers. Um, we will be configuring this pipeline now because this is where we tell Jenkins where to find our code and our pipeline definition. So crucially, this is where we will set up the automated check for new code. So we'll go to the trigger sections, checkbox this whole SCM, and this will tell the Jenkins to periodically check the GitHub repository for new commits. So in the schedule field, type star 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 5 times, and in the schedule of this star star means Jenkins will check the GitHub repository every minute for new code. If it finds a new commit, it will start a build. This achieves our goal of automation while keeping Jenkins local. So we'll scroll down to the pipeline section now. So for the definition drop down, select pipeline SCM, pipeline script from SCM, and the SCM will be Git. And in the repository URL, I will paste the GitHub repository, my GitHub repository's URL. I will copy this HTTPS URL and paste it in this pipeline repository URL. Perfect. So let's move a bit, scroll down. Credentials should be none because it's a public repository. Ensure that the branches is set to branch to build basically. It should be set to master or main, whatever your build branch name is. My main branch is main. So I will specify main and then I will scroll down and click on apply and then save. Perfect. So the job is now configured. Let's kick off this very first build to make sure everything is connected correctly. I will click on the build now option to manually trigger the pipeline. You will see a build appear in the builds history on the left. It's building now. Let's click on the build number and then on the pipeline steps. It's running basically. So we are seeing the visual pipeline. We can see our stages like checkout, build, and test. The checkout stage pulled the code and the build stage ran our simulated build commands and the test stage ran our successful test scripts. We have a green check mark as successful pipeline. So the real magic of CI/CD is automation. We want Jenkins to run this every time we push code to GitHub. Since our Jenkins is running locally, we will set set up poll SCM to check for changes every minute. So now let's go back to the GitHub repository and I will open the Jenkins file and I will click on the pencil icon to edit this. Okay, I am not signed in. Let me just sign in quickly. Okay, just give me a moment. I have to enter the code that I had set the multi-factor authentication on this for the GitHub. So let me just enter the code. 527,718. Perfect. So I'm logged into this GitHub repository now. I will click on the pencil icon again. Let's see. Perfect. So now I can edit this file and I will make the change. So I will make a small harmless change in this file. Let's say building the application again. And I will commit the change. I will make sure just auto verifying automation. I will click on commit changes, go to the Jenkins dashboard, go to the pipeline again. Let's wait for a few seconds. A minute basically because we have scheduled the poll to execute every minute. So we would have to wait for a minute because it's checks for the new commits every minute. So we have already committed the code in the GitHub repository and we are now waiting for Jenkins poll SCM schedule to kick in. Let's wait, let's refresh in case it is not. Great. So as you can see, this build has ran successfully and you can see the test pass successfully, build completion, and the message that we have added, build the application again. So our job has been kicked in and we have verified in the build history as well. The build number #2 has automatically started. We didn't click anything in Jenkins. We just refresh and I was just verifying whether configuration is correct or not, but we didn't build this manually. So Jenkins detected this change in our GitHub repository and sprung into the action. This is the essence of continuous integration. So I have verified all the stages are run in step 2. So a key function of CI is catching errors as well. Let's make a change that we know that will break the build. So I will go back to the GitHub repository. I will edit it again and I will replace the I will specify something that can fail. So I'm adding the build complete building the application. Just after building the application, I'm specifying exit 1 and then I will commit the changes. I'm saying that intentionally basically we are intentionally exiting the code and commit changes. Perfect. Let's go back to the pipeline and let's wait for a minute to the build to be triggered. Great. So there it is. The build quickly run. Build is basically running. Let's wait. Oops. So as you can see, the build got failed. The build turns red, a failed build. This red circle means the red circle with X is the immediate feedback that it's failed. The visual pipeline clearly shows that where the process stopped, as you can see. So when the building the application again, just after that we place the exit one, so that's why it failed after just after that. So we can scroll down to see the error messages, script returned, exit code, and all those errors, exit found. So there you have it. In just few minutes, we went from an empty Windows machine to a fully functional CI pipeline. We installed Jenkins and its core plugins. We created a job linked to a GitHub repository using Jenkinsfile. We configured poll SCM to check GitHub for changes. We watched a successful build running all the stages. We triggered an automated build simply by pushing a commit, showing how Jenkins automatically checks for and builds new code. We also saw how Jenkins immediately gives us the crucial feedback that is the red flags to identify a broken stage and quickly fix it. This continuous feedback loop is the core power of CI/CD, helping teams to deliver the stable code faster than ever. Okay, so to summarize, Jenkins is an incredibly powerful and flexible tool that's been a foundation of DevOps for years. Its ability to automate builds, tests, and deployments, combined with its vast plugins ecosystems, makes it a must-have for any serious CI/CD setup. The key takeaway is to embrace pipelines as code to make your workflows reproducible and version controlled. In our next video, we'll be starting a brand new series focused on a highly requested and very valuable topic, that is AWS Certified Cloud Practitioner Certification. This is a perfect entry point for anyone new to the cloud, covering the fundamental concepts, core services, security, and billing models of AWS platform. Don't forget to subscribe so you don't miss the beginning of this essential new series basically. Thank you.